Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in short range wireless communication. We're going to see the working principle of repeaters, right? This is going to be a very interesting topic. Repeaters in RF communication plays a very vital role. And first you got to understand what is repeaters. Repeaters normally what it will do, it will regenerate the signal so that it will boost the signal so that it can able to be transmitted at the longer distance, right? It is very similar to amplifier, but here it does not just amplify the signal, it will regenerate the signal. That is, it receives the weaker signal, it will demodulate that particular signal, and that demodulated signal, that is the original signal, will be again modulated by using a transmitter so that it will be transmitted to a much longer distance, right? Whereas if you're going to transmit the original signal, it will not be received to a very longer distance without the repeater. But by using the repeater, we can use the original signal to travel to a very longer distance. You can see here, right? This is repeater. That repeater will receive the weaker signal. It will amplify that particular signal, and that signal will be received by the original receiver, so that the original receiver will receive the original signal as it is without any degradation. That is the purpose of repeater, right? So the only drawback in repeater is it has ping pong effect, right? And we will see what is ping pong effect, how to overcome ping pong effect after seeing the working principle of repeaters, right? And as I said, repeaters, what it will do, it will just receive the weaker signal, and that signal will be detected, that is demodulated. It will detect the original signal. That original signal will be modulated by the transmitter so that it will be received by the original receiver with the same as like the original signal, right? And this repeater can be used uh, continuously, that is in a chain basis, so that we can able to transmit the original signal to a very longer distance. And this is predominantly used whenever we have a lot of limitations in using low power devices. That is, low power devices is very limited to frequency range, and as well as the communication link is very uh, not very reliable, right? In that case, we will use repeaters, right, which is allowed by the telecommunication standards. And as I said, it will just receive the weaker signal, and it will demodulate that, and it will recreate the original signal. That recreated signal will be transmitted, which is modulated and then transmitted, which will be received at the receiver, right? And exactly what it does is it performs the relaying of the signal, right? In digital systems, it will be like relaying the signal from one receiver to another receiver without any particular errors, right? And the repeater has its own receiver and transmitter, which act in the same frequency of the original transmitter, right? And as I said, like the repeater will receive the signal, demodulate it, and then it will transmit, right? It will take, there will be some sort of a delay, and that delay is also very important to overcome the interference, because the transmitter, the original transmitter, is also work in the same frequency as the repeater, right? So the repeater has to wait until the original transmitter completes its transmission, right? So that it will overcome that particular interference. So there will be a significant delay in using the repeater. That is to avoid the interference. And the predominant problem here is there are chances that the repeaters can repeat the same signal, or a particular signal can be sent back and forth between two repeaters. That can be done, right? That can be a problem in repeaters. That is, when you use more than one repeater, there are chances that the repeater which is closer to the transmitter can repeat that particular transmission, or else one particular signal from a repeater can be sent back to the same repeater, so that it causes the ping pong effect, right? That is, a signal can be sent back and forth to the same repeater in a loop, right? This will create congestion and this will degrade the uh, performance of the particular system, right? And this can be avoided by using message protocol identification of the repeater so that the repeater will ignore the message if it is received from the same device. And similarly, another way is to force a time delay after transmission of a frame, right? But this problem happens whenever there is a coverage issue between the repeaters. If two repeaters have uh, interference with the coverage area, that is, if it has interfering coverage area, then this ping pong effect will be very more, right? And you can see these are the reasons of ping pong effects. Overlapping coverage areas, as I said, if two repeaters overlap the coverages with same frequency, a signal may keep getting retransmitted between them. That is the ping pong effect. And improper configuration of repeaters can also cause ping pong effect. If the repeaters is not properly set, or if not properly set with proper filters, and there is no proper timeout or no proper logic in retransmission, then it will create this type of problem. And there are chances that feedback loops can happen. That is, if a repeater mistakenly receives its own signal, then it will keep repeating the transmission again and again, right? And even network issues can happen, network topology issues in mesh or linked repeater system. Improper routing can create loop where packets keep bouncing between the source and the destination, right? These are the various reasons for ping pong effect, and uh, this ping pong effect can cause serious effects with network congestion, that is, causes unnecessary traffic, reduction in bandwidth, and it can cause latency and delays, increased transmission time due to repeated of forwarding, system instability, and similarly battery can drain, because in wireless devices battery plays a very vital role, and this continuous retransmission can lead to drain of power, right? And these are the effects of ping pong effect. And this can be some notable solution. We've already seen two important solutions. They can be a proper solution to prevent the ping pong effect. That is, adjust coverage and power levels. You got to ensure that repeaters do not overlap with each other. And similarly, proper routing filters, right? We have to use a proper routing filters to overcome this ping pong effect. Using directional antenna can also help to avoid signal reflections, and configure timing and handover settings in cellular or Wi-Fi networks. This particular repeaters plays a very vital role in RF communication, especially in cellular and Wi-Fi networks. And if we can able to filter this ping pong effect, that is, we can able to uh, configure the repeaters and configure the coverage area of repeaters properly, then repeaters can work very fine and we can able to receive the signal without any problem. That is, the original signal can be transmitted to a much longer distance using repeaters, right? So today what we have seen is we have seen the working principle of repeaters. I believe this video will be very useful for you. Thank you, my dear students.